Today here on the bench a Kenwood 2-meter all-mode transceiver TS-700S. Welcome to TRX Bench. Alright, and let's go here into the video. So this receiver came in with an S-meter problem. So if we listen here into the background, so we can hear that the transceiver is receiving without no problem, and the sensitivity is just fine, so no problem. But you see there is no S-meter deflection, but it should be a S9 for the signal I'm putting in here into the radio. And secondly, you see there is no S-meter illumination, so the light bulb is gone. And as well, we have here the same with the frequency dial, so the light bulb is faulty as well. So these lights here are fine. But finally we have two lights with which we have to replace. But I think the most interesting issue is here our S-meter problem. So that could be interesting. We will see. So let's crack open here our radio and see that we get here to our S-meter amplifier first, and if our S-meter is back running, then we go and replace here our lights. Alright, so the first check what you ever can do if you see an S-meter problem, and as I said, we are feeding in an S9 level, so you see nothing here, but we have here our RF gain potentiometer, and when we turn it and we see, as we do, that the S-meter is moving, that is then finally telling us that the meter itself is working, and we know that the needle is not sticking to a mechanical problem or whatnot. So that is what we clearly can see. So that is always a very good first test, and we know that it is working. I mean, what we are doing here is basically very simple. So you may ask what this RF gain adjustment does. So you are simply changing the AGC, and the AGC is the automatic gain control, right? So what is it for? Very simple. If you get a very strong antenna signal into your radio, then you do not want to get your front end overdriven, and therefore the automatic gain control is noticing that there is really a strong input signal, and it that then will reduce the amplification of our front end, let me say, transistors. Okay, so you can change the amplification with the automatic gain control. Okay, so if there is a strong signal, we have a certain DC as automatic gain control, where you can control your front end amplification factor, right? And if the signal, the input signal is very, very weak, then of course you need the full amplification factor of your front end. And that means that this DC is always an indicator for how strong a signal is. I mean, dependent on your radio, dependent on how it is designed, you will get a positive AGC. So if you want to reduce the input sensitivity, or it is a negative voltage, but it is always a DC voltage which will control your front end, right? And you use this AGC because it is in some relation with your antenna signal, right? You use this DC voltage for powering your S-meter. So that is the whole magic behind it. And therefore, if we are turning here our RF gain, right, you're doing nothing else than changing manually your automatic gain control. Now it is not automatic anymore, now it is manual, but it is a gain control. So you are changing your DC voltage towards your front end, and therefore you can reduce your input sensitivity, and that is what you want if you have a real strong signal. And therefore this here is always a very good indication if your circuit is working in general. So we now need to find why we do not get here you know, an amplification. Alright, and to make it a little bit more clear what we are talking about here on our RX noise blanket unit, we have at least our S-meter amplifier, and yeah, let me enlarge it here a little bit for you, and then we can easily see that we have here our meter and our, maybe that was a bit too much, and here on this circuit we find our Q6. This here is at least our S-meter amplifier, and we have here our buffer. And what we easily can see that here our buffer is connected to, oops, you can't see it, sorry, that it is connected to our AGC, so to our automatic gain control, right? And that simply means we can measure our signal strength with the S-meter by simply using here our AGC, and well, we can simply check our AGC and what will happen when we adjust our RF gain control, because then we must see our automatic gain control changing to another value. I mean, a positive or a negative value, as I said, depending on the design of our circuit. And down there we have our RX noise blanker unit, and I have now connected here my meter to our AGC test point, and what we can see, so I hope we can now see everything. So what we still can see is there is no needle indication, and at our AGC test point we can read 2.8 volt, and we have seen by changing here our RF gain control, right, we have seen that the needle comes up, and once again if we do it and watch here our AGC voltage. So you see that as lower our automatic gain control voltage is dropping, you see that our S-meter here is coming up. And I really can take it here to a negative voltage, as you can see. Now we have minus 1.5 volt, and that means that now with this AGC our complete front end is as less sensitive as possible. So that means even with a very strong signal into our receiver, we really will not be able to read the station even with a very strong signal. And that is what we can hear. So back here to 0, so that means our RF gain is fully clockwise, so that means we have full amplification, okay? And if I switch on our speaker, I can do it a little bit lower, so you hear that there is a very good reception of our signal. So that would now be our distant end station. And now I go and reduce our input sensitivity, and you can hear it now. Now we are losing our signal, and now it is completely vanished here in the static. And that clearly shows that we really have reduced our sensitivity to a max, and that means no sensitivity any longer. So what we know up to now is that our meter is working electrically and mechanically. We know that we are able to change obviously our AGC voltage, and by changing our AGC voltage we see that here our voltage is changing and the sensitivity is changing. So that all is telling us that it is working fine, but still we do not have an indication with a signal, which we have of course, and you hear it is a very good and clean signal. So let me switch off here the speaker and let me show what we have here on our communication tester. Okay, so what we can see here is that we have really a very nice synod here, and you see that we have a nice and clean sine. So that all is an indication that we have really a strong signal. And you may remember we are talking here not about shortwave, because with shortwave minus 73 dBm would be S9, and with 2 meter and 70 centimeter we have different parameters, and with minus 93 we have an S9 level. So that is what has been agreed, and therefore you see this is an S9 level, and we have a very, very nice synod, and you see our distortion level is quite low, so everything is nice, but we do not have an indication on our S-meter, right? The question is now, what happens if I increase here my signal level? Does it make any difference to our signal meter here, to our S-meter? Let's see if it will move if we increase our generator level. Okay, and that really might be a good try, because we know that basically the circuit seems to work. So we now increase here our level. Let me take down here the annoying tone. Let me increase our level, and now it is 83, and now we have 70. Oh, hello. So already we have here obviously a signal, and you see it is an S5, and that means that maybe it is only an alignment problem. So you see I'm moving here my input signal, so let me increase it more and more, but now I'm really here sending with a very high level, and we still have only already S9, which should be much higher, and that means that obviously here the alignment is not good. But on the other hand, I'm really interested what the sensitivity will be, and therefore I reduce here back our input level until we get a synod of 20 dB. Yeah, 20 dB, and we have here a sensitivity of, let me double check, we have a sensitivity of 0.5 microvolt, which is very good with 20 dB synod, of course. So that is just fine. So that means that the sensitivity of the radio is no problem. It really seems to be that we have an alignment problem. So let's try if we are able to simply align it to the right level here. Okay, and the first we need to do is to adjust here the 0 point. So it will be the point where the needle just starts to deflect. Yeah, therefore watch here our meter. So we have to set our generator to RF signal off, so that is what we have done. Our RF gain control is fully clockwise, so we have highest sensitivity. So you may hear here the static, so that is clearly indicating that we have no signal. Now we go down here to our control in the radio, and now we have to, and you see I'm really able to adjust here my control. And what we need to do is when we have to set it where it just starts to deflect. So that means we really need to set it to the 0 point. I hope that that is what we need. And then we have to go ahead, of course, with our S9 adjustment, and I just hit it here, and we are already on S9 with, so our service manual is telling us with 10 microvolt, which is minus 87. So the level is a little bit higher than the agreements today, where we say it should be minus 93, where we have to reach our S9 level. a couple of years ago it was obviously agreed to set it with 10 microvolt, which is minus 87 dBm. Anyways, so our generator is now set to minus 87 and our deviation is switched off, so that's the reason why we do not hear a tone. We only see the carrier, and we see that with our potentiometer here on the RX noise blanker unit, we were able to adjust it now to an S9 level. So let me put back here our tone. So now we have back deviation, and let's see what's going on here. Oh, and we have seen all the reaction when we switch on here our modulation. So now everything seems to be fine. So of course we are on FM, and when I now switch, so that is what I just did, our modulation back in, you see dropping here our S-meter, and that is of course telling me that there is a bit more wrong than only our S-meter adjustment. And I've also recognized when I was poking here around a little bit. So let me switch off here my modulation, and let me simply switch here our radio to upper sideband, and you recognize that I have a tone, even that, you know, I should not have it, as you know, I should have a tone here on 289, and you see that is not given. So I really have to increase it, and you see here that the S-meter is coming up, and that all is really telling me that the frequency setting here in the radio is wrong as well. So we really have to set the master oscillator and the local oscillators and whatnot to be able to have the right preset, and then we can go through our FM board and our RX noise blanker board, because we get informations for our S-meter adjustment on FM. So we get a feedback voltage from our FM unit. Okay, and just that we all know what I'm talking about. So we have here our RX and noise blanker unit, and yeah, let me zoom it in a little bit, then it might be easier. But down here we have our FM IF unit. So that is what we need to understand, and let me zoom it in here a little bit. So what we need to know is that we have here our S-meter amplifier. Here we have our meter, our S-meter, and what you see is that our S-meter amplifier will get its DC voltage here from this buffer. And when you look here to this connection, right, you find that we have here our AGC line, and when we follow our AGC line here down to our AGC amp, our amplifier, you see our AGC amp is here, okay? And the AGC amp gets fed, at least here, from our IF amplifier, and you see that from there, right, our AGC amp gets fed, and this is of course, and simply due to this diodes especially, we are handling here DC. So our AGC is DC, and that is a story what I've already explained in the beginning. So you see that the AGC is coming up here to our signal amplifier, and you see it is going back here to our RF amplifier. So the AGC is able to reduce the sensitivity if we have really a huge input signal. So that is the whole story, because if there is a huge input signal, then our IF amplifier has to handle a big signal, and our second IF amplifier as well, and that means that of course we get here a very high DC voltage, okay, and this DC voltage gets feedback to our signal amp and RF amp, and so this both amplifiers can be regulated by the incoming signal. And you see here that our S-meter amplifier will get this DC voltage right from our AGC line, and therefore very easy our S-meter gets output DC right to our S-meter depending on the level of our AGC, and that is what we have seen on our voltmeter when I was changing the input level, that we had to changing AGC here on this line, and that is why our meter is moving. Now we have seen that on SSB our S-meter is working just fine, and you see that here right behind our IF amplifier we have the SSB detector and the AM detector, right? So that is working fine, but when it comes to FM, all has to go here through our FM IF unit, and you see here at the FM detector, right, we feed back here a signal right back here to, let me pull it down here, right back here into our DC amp, okay? And you see the voltage from the DC amp and here from the S-meter amp gets at here at this point and then goes to our meter. So when we are losing our signal, when we engage our modulation, something must be wrong here with our DC amp, or maybe at least here our switching. So I don't know, we need to find it out, but because I've seen that the oscillators, the main oscillator and maybe the local oscillator is not working right, so we are off frequency, we really have to perform a complete alignment first before we really can tell is it only an alignment problem, because you easily see that we have here a pot where we can adjust the level which gets feedback to our DC amp here, and so forth and so forth. So therefore, to be sure that it is not only an alignment problem, we need to perform our alignments. So I have to go through all the steps, and then when I finally have aligned here our FM-IF unit, which is this here, of course, then we know what's really going on. And well, by the way, while we are doing this alignment, I mean here on the FM-IF unit and on the RX unit, which the RX noise blanker unit, which is this here down below, we adjust accordingly the sensitivity of the radio. So that means we really perform a sensitivity alignment and a master frequency alignment, and so we are really going through our whole receiver unit, and once that is done, we see if then our S-meter will work properly or not. If not, then we know there is definitely an electronical or mechanical failure somewhere down here in our circuit. But now let's first go for the alignment. Okay guys, and well, you know that we had the problem here with our S-meter on FM, so everything was just fine with SSB, so we had no problems there, but we had problems here on FM, and now you see radio switched to FM, and I'm receiving a signal here without modulation. So you see we are on S7, and we had the problem that the S-meter was falling down when we switched on here our modulation. And now when I switch it on, you see we are stable at S7, so there is no S-meter movement any longer. So the story is I really aligned half of the radio, and when I say half of the radio, that really means that I did not really a proper job here on this radio, simply because of the fact that you know, it is not a real repair any longer. So this is a radio, it is older than 40 years, so I don't know. So this is in or is from the early 70s, and this radio is really difficult to repair. Why? Simple. After such a long time, we really should recap the whole radio. First, we should recap it. After recapping, we need a complete alignment on FM, not on FM, on TX and on RX. And that means this will really take a long time. So 10 or even 20 hours is easily to put into this work. And you see, then it is definitely no repair any longer. So then it is really a restoration. But this radio came in for a repair. And remember, what the owner requested was, can you put me new lights here in the front at the S-meter, and well, can you have a look to the S-meter? Maybe something is wrong, it doesn't work. And you know, it came in for a repair, but it turned into really a restoration job. And so I did already too much here on this radio, so it already really took too long to align the radio in a way that we can use it. But still, there are problems. And let me go down here a little bit. So if we start and recapping the radio, so that is another story. So have a look here to this connectors. Don't know if you really can see it. So this is this so-called wrap technique, which has been used in the 70s. So the wire was twisted here around the pin with a special machine for it. Was really a nice idea in its years, because it was very good for production, even faster than soldering all these connections. But on the other hand, I'm not easy able to get let me see, I'm not easily able to get a board like this down here out of the radio for recapping, because I cannot simply take here a connector. So here is one connector in the radio, only one, but all the other wires are here connected with this wrap technique, and you know, getting all the PCBs out would really mean a lot of work, and then you have to recap it. So I would not really say that this is a job for a repair shop. So this is more a job for a retired ham radio operator who can do it in his spare time, which you of course have as retired ham radio operator. Then you can say, all right, this is really a nice radio and I love it, and I really want to make it like new. Okay, so that is then a complete different story. But you know, if a radio comes into your workshop for doing some bulb replacement and for looking after the S-meter, and then it turns out that there are problems, and there is as well a problem here in our in our power supply, which has a problem with some regulations here, which turned out when I checked it, and I believe it is due to caps which really needs to get replaced. But once again, I mean, the owner is not really willing to pay for a restoration. So you know, you are always in trouble if you have something like this. So I decided, okay, I do it in a way that the person can use the radio, but you know, it is not really for long term, and it is not a high quality work which I was doing here on this radio. But you know, I just wanted to share with you these thoughts, because then you might see what it means if you have a situation like this here. Okay, and I'm working here on the new illumination. So we are using here, of course, LEDs, which I have already prepared here. S-meter is already done here, so you see it is nicely shining up, and yeah, this is now here our LED, which goes here behind our dial, and then we have our lighting under control as well. Alright, and our dial backlight is back as well, as you can see. So everything is done here, so light is just fine. So it is always nice to see how nice these LEDs turn out. So that is great, and yeah, so that is done. Alright, job is done. I hope I was able to do this ham radio operator a favor. If you ask me if I'm satisfied with the work, no, I was not. So I know that there are still a lot of little problems here in the radio, and that is simply due to the fact that the radio is 40 plus years old, and normally, as already said, this radio would really need a completely restoration, which mainly means it needs to be recapped, and we have not done that. That means that this radio is not able to deliver its full performance, but it is working, so the operator can use it, and it is better than before, but it is not perfect. And well, so I wouldn't have done it if this would be a complete unknown person, but he's known, and so I hope that we really can do him a favor. And so that's it for the day. Thank you for watching. Hope you enjoyed it a little bit, of course, or even it was a little bit of a disaster. But anyways, thanks for watching, and catch you next time. Bye.